In this training exercise, we will be discussing the changes since last firm, or CSLF, dataset from the Flood Risk Database, or FRD. At first glance, this dataset can seem complicated, but utilizing it properly can make it an extremely powerful tool. In the following video, we will give an overview of the dataset, demonstrate how to implement some best practices for visualizing the dataset, and go through an example to show how the dataset can be used to help answer real-world questions. The data within the FRD benefits users from numerous backgrounds. Whether it be government officials, users from the private sector, or citizens, each can find value in the CSLF dataset. Benefits include capturing changes in mapped floodplain and floodway boundaries, as well as flood zone designations. This makes it easy for communities and homeowners to identify the impacts of new maps on the regulatory floodplain. When comparing the old and new floodplains, one can easily decipher increases and decreases in the floodplain, which assists in prioritizing mitigation actions. In the next sections, we will demonstrate how to use the CSLF dataset within ArcGIS to perform analysis in a scenario that will simulate real-world implications. We will now investigate how to properly set up an Arcmap document, how to change the symbology of a particular layer in an Arcmap document to easily visualize the data, and finally, perform an exercise to discover how many parcels are being newly identified by the revised study being performed in the city of Talladega. For the initial Arcmap setup, open a blank Arcmap document, or MXD. Click the Add Data button and browse to the CSLF dataset within the FRD. Once the data is located, select the Changes Since Last Firm feature, the Political Area feature, and the UDF point feature, and add them to the MXD. We will use the Political Area dataset and the UDF point dataset to help us complete the example later on in the training. For now, we will focus on symbolizing the Changes Since Last Firm dataset to maximize its use. The amount of information contained in this dataset can be overwhelming, so we will start by defining some of the key fields in the attribute table. Having a clear understanding of these fields will make the dataset easier to query and symbolize in a fashion that is easily discernible. This slide gives an overview of the key attribute fields and associated domain values, which are further defined in the FEMA guidelines and specifications. You can refer back to this slide as needed throughout the exercise. Now that the pertinent fields have been examined, we will begin changing the symbology to display the values. In order to see both the floodway changes and the special flood hazard area changes, we will copy the Changes Since Last Firm dataset twice. To do this, right-click on the feature and select Copy. And then right-click on the layers and select Paste Layers. Repeat this process one more time. Now, right-click on the Changes Since Last Firm layer and click Properties. Select the Symbology tab, click Categories, and choose Unique Values Many Fields. In the Value field drop-downs, choose Pre-Zone ST, New Zone ST, and Floodway Change. Select Add Values and click Complete List. Hold the Control key down on your keyboard and select the following. Selecting these values will group the features to display only the areas of floodway increase. Select all of the layers, right-click, and select Group Values. Click the label of the group of values just created and rename it to Floodway Increase. Right-click and select Properties for selected symbol. Choose Floodway Increase. Repeat this process again with the following values to display only the areas of floodway decrease. And then once more with the following values to display the areas of no floodway change. In Arcmap, uncheck the All Other Values group so that we only display the group of values that we just created. Rename the Changes Since Last Firm feature to Floodway Changes so that we know that this layer is only showing our grouped values that are associated with the floodway. To display the changes to the special flood hazard areas, right-click on the next Changes Since Last Firm layer and select Properties. Select the Symbology tab, click Categories, and then choose Unique Values Many Fields. In the Value Fields drop-down, select Pre-Zone, New Zone, and Special Flood Hazard Area Change. Select Add Values and click Complete List. Hold the Control key on your keyboard and select the following values. Selecting these values will group the features to display only the areas of 1% annual chance increase. Note, no value represents a blank space in Arcmap. Select all of the layers, right-click, and select Group Values. Click the label of the group of values just created and rename it to 1% annual chance flooding increase. Right-click and select Properties for selected symbol. Choose the 1% annual chance increase. Repeat this process with the following values to display only the areas of 0.2% annual chance flooding increase. Repeat this process again with the following values to display only the areas of 1% annual chance flooding decrease. Repeat this process again with the following values to create the 0.2% annual chance flooding decrease. And once more, repeat this process to display the values to create the areas showing no change. Now, uncheck the All Other Values group so that we only display the groups that we just created. Rename the Changes Since Last Firm layer to Special Flood Hazard Area Changes. Now that we have symbolized the dataset to easily view the different groups, we will use it in an exercise. In this exercise, we will determine how many parcels are being newly identified in the floodplain by the revised study in the city of Talladega. We will first query out the city of Talladega. To do this, right-click on the political area, select Open Attribute Table, right-click on the political name 1, and click Sort Ascending. Now select the city of Talladega. Now to determine how many UDF points are within the city of Talladega, we will perform a select by location. Click Selection, and then Select by Location. Select features from UDF points as the target layer, and the political area as the source layer. Check the Use Selected Features box. Set the spatial selection method for target layer features to are completely within the source layer feature. Click OK. Right-click on the UDF layer, click Open Attribute Table, click the selection box. This shows 506 points are selected. Right-click in the data frame and click Zoom to Selected Features. We will now set a definition query on the Changes Since Last Firm dataset to display only the areas of floodplain increase. To do this, right-click on the Changes Since Last Firm layer and click Properties. Navigate to the Definition Query tab. Click the Query Builder box. Double-click Special Flood Hazard Area Change. Click the equal sign. Click Get Unique Values and double-click Increase. Click OK and then OK again. We will now determine how many of the previously selected UDF points are within the area of floodplain increase by performing another Select by Location. Click Select, Select by Location. Set the Selection Method drop-down to select from the currently selected features in the UDF points. Set the source layer to the Changes Since Last Firm layer. And set the Spatial Selection Method for target layer features to intersect the source layer feature. Click OK. Right-click on the UDF point. Click Open Attribute Table. You will see that the original 506 UDF points have been reduced to 181. These are the parcels that have been newly identified in the floodplain by the revised study in the City of Talladega. This concludes the training exercise. You can now use the methods shown here on your own Changes Since Last Firm dataset.